My friend Mathis is one movie buff. Every other day, you can find him browsing DVDs in stores, buying films and so on. So he visits stores very often, and I asked him to do me a favor and pick up a Spanish film that I had been searching for quite some time. But apparently, not only did the parlor not have the film I was looking for, but in fact, it didn't have a single Spanish film. Now where do sets figure in this situation? I'll enlighten you on this in today's episode. So stay tuned. Hello and welcome to Math 11. First, let me introduce myself. I'm Shankar, your mathematical travel guide, and this is the only place where you can watch TV and get educated at the same time. You know, people would have laughed at the idea in the past, but that was then and this is now. I can promise you that if you undertake the mathematical journey with me, you'll learn more and score more in your examinations. For math is all about numbers, and here on Math 11 is where we crack them. In today's episode, we're going to learn about sets and see how they are different from a collection. Our goals are to understand the two methods of representation of sets, what an empty set is, learn about finite and infinite sets, and learn about a few new terms related to these concepts. And of course, no episode is complete without the vital exam decoded section. Have you wondered what kicks off any journey into mathematics? You're right, the concept of a set. The theory of sets is a basis for knowing more about relations and functions, probability and statistics. Now, before going to sets, let's first understand what exactly a collection is. People usually talk about collections in terms of objects like a pack of cards, a group of students, a cricket kit, or the crockery items in a shop. In mathematics as well, we come across several collections. For example, odd numbers, various types of triangles, and such. In all of these examples, did you notice that the objects in a particular collection have something in common between them? Well, they do, which leads us to our main topic, sets. We now have a few questions for you. How do we define a set in mathematics? Are there any new operations involved? Who was the first to introduce this theory? Well, that's what I'm here for, to tell you how and why. It was a Russian-born German mathematician named George Cantor. He encountered sets while working on problems in trigonometry. As with many great people, Cantor was baffled by what he discovered during his journey through sets. He met a lot of opposition from mathematicians of the time, but his concepts have come to prevail today. According to Cantor, a set is a well-defined collection of objects, in the sense that we can definitely decide whether a given particular object belongs to a given collection or not. So if I ask you, is Shoaib Akhtar a member of the Indian cricket team? Your obvious answer is no. And now if I ask you, is Shoaib Akhtar a cricket player? The answer is a resounding yes, of course. Notice that here we were able to decide either way to answer the question with respect to a certain idea or property. Alternatively, if I asked you to pick the 5 best mathematicians in the world, it's a little difficult, as the criterion to pick up the best is not uniform, meaning it changes from person to person. So the collection of best mathematicians is not well defined. Some more collections that are not well defined are beautiful actresses, for example. Beauty, as they say, is in the eye of the beholder. Most popular sports person. These are your examples of not so well-defined collections. Now let's explore some more about the notations and definitions in set theory. After defining a set, we go ahead and label them with capital letters like A, B, C, X, Y, Z, etc. The objects in the collection, they're called elements. We use the symbol to denote that a particular object is in the collection, and the symbol to denote that a particular object does not belong to the collection. So if A is an element of the set A, we write A belongs to A. And if it is not in the set A, we write A does not belong to A. Next on the menu is the two methods of representing a set. One is the roster or tabular form, and the other is the set builder form. In the roster form, the elements are separated by commas and enclosed within curly braces. For example, the set of all even positive integers less than 7 is given in roster form as curly brace open 2, 4, 6 curly brace close. Next, the set of all vowels in the English alphabet is given by A, E, I, O and U within curly braces, of course. Remember that in roster form, the order in which the elements are listed is immaterial. So good so far? Now let's consider the second representation, the set builder form. We know that all the elements of a set possess a single common property that is not possessed by any element outside the set. For example, take the set 1, 2, 3, 4, 6, 8, 12, 24. All the elements possess a common property. You're right. Each one of them is a natural number and each of them divides 24. No other number possesses this property. Denoting this set by X, we write X is equal to elements X such that X is a natural number and X divides 24. In this notation, we use the letter X to indicate the general element. The colon separates the general element from a property that defines what membership in this set is. If there is some element that obeys this property, then it belongs to the set. The set builder form is useful in two instances. In the first instance, we know the property but don't have a handle on all of the elements that satisfy this property. Consider the prime numbers, for example. In the second case, the set is purely infinite. We don't have the energy to list all of them. Okay, I think I've rambled on for long enough. Time for a break. When you come back, we'll be getting into more sets and looking at some examples of set theory in practice. Math 11 will be back. See you then. Welcome back to Math 11 with me, Shankar. Are you all set to get back into sets? Pun intended. Right, let's move on because I can crack some more bad jokes otherwise. Prior to the break, we discussed two ways of expressing a set, the roster form and the set builder form. We shall now get some practice with them. First, the roster form. Express the solution set of the equation x squared plus 7x plus 12 is equal to 0. Using the quadratic formula, we get the roots minus 3 and minus 4. So the solution set in roster form is curly braces minus 3, comma, minus 4, curly braces. Here's our next question. Given the set PRINCAL in roster form, write the same set in the set builder form. Now look at the letters PRINCAL. One possible answer in the set builder form is the set X such that X is a letter of the word principal. Of course, this answer is not unique. Can you think of any other? Hey, here's one more. X such that X is a letter used in the phrase call rain in April. Interesting. Why would anyone want to call rain only in April? Never mind. I just can't help myself today. Anyway, till now we discussed sets and their elements. A set having elements is called a non-empty set. But is it possible to define a set which has no elements? The answer is yes. And guess what? This set is as meaningful as the number 0. Its importance is not to be underestimated. Let me take you back to the DVD parlor. The Spanish film was not there. In fact, the parlor did not have any Spanish films at all. Do you know what it means in mathematical terms? A null set. Let me explain this to you. If I asked you to write the set of integers between 2 and 3, what would you do? You already know that there are no integers between 2 and 3. This means there are no elements in the set. Such a set is called null set or empty set or void set. We denote this set by the symbol phi in the Greek alphabet. We also write this set as 2 curly braces with nothing in it. After all, the null set has nothing in it. Here's another example for a null set. Consider the set X such that X squared is equal to 9. X is even. Easier said than done. There are no numbers that match those properties there. Sets can be put into 2 categories: finite sets, infinite sets. A finite set is a set with a definite number of elements. For example, the set of vowels in the English alphabet is a finite set because there are exactly 5 elements in this set. Furthermore, an empty set is also considered as a finite set. It has 0 elements. Now tell me, is the set 0 a null set or not? Well, it's not a null set as it contains one element 0, making this a finite set with one element. A set that is not finite, you guessed it, is called an infinite set. The set of points on a line segment is an infinite set as the number of points between the ends of the segment is not definite. So would you say the set X such that X is a natural number is infinite? Well, if you want the right answer, you would say yes, as there are infinite natural numbers. Here's how. Suppose that this set is finite. Then we must have a greatest natural number n. What about n plus 1? Hey, that's also a natural number and must therefore belong to this set. We have a contradiction. This set of natural numbers, it must be infinite. But what about the set of stars in the Milky Way galaxy? Are they finite or not? Considering the size of our galaxy, you might think otherwise. But the answer is, it is finite. Based on the Milky Way's mass, it's thought to be about 200 to 400 billion stars in it. However big this number is, it's still a definite number. That's what matters. Aha, looks like there's someone on the line with a question for us. Let's see what the caller has to say, shall we?
Hello sir, my name is Neha. Your show has been a great help to me during my exams and generally throughout my course. My question is this: is the set of all women in this world is finite or infinite?
Thank you for that thought-provoking question, Sneha. I'm glad the show has been helpful for you. To answer this question, the set of all the women in this world is finite. You see, although the exact number of women at a particular time is not known, it would still be a definite number. So we say that the set of all women in this world is finite. Moving swiftly along, we now come to equal sets. Two sets A and B are equal if they have exactly the same elements. The set A is equal to x such that 2 less than x less than 15, where x is a prime, and B, which is equal to 3, 5, 7, 11, 13, are both equal. The set C is equal to x such that x is a letter of the word alloy, and D is equal to x such that x is a letter from the word loyal, are both equal. We can see that both of these sets can be written in roster form as L, O, Y, and A. Here's what I've got for you today. There's a village with a male barber who every day shaves every man who doesn't shave himself and nobody else. The big question is, does the barber shave himself? If your answer is yes, of course, he shaves himself, think again. The barber shaves only those who cannot shave themselves. So you would be wrong. If your answer is no, he won't shave himself, then he must go to this barber who is himself. So this can also not be a right answer. This situation is called Russell's paradox. Bertrand Russell, the discoverer of this paradox, was a famous mathematician and also a Nobel laureate. Now you all know there is no Nobel Prize for mathematics. Well, Russell was awarded one for literature. It was Russell's paradox that led all the contemporary mathematicians of that time to take a good hard look at the very foundation of the definition of sets. On that note, let's take a break and catch our breath, because we are going to need all of our energy in the upcoming exam decoded section. So stay tuned. Hello again, I'm Shankar and this is Math 11. So far we've been looking at sets and notations. And in case you're just joining us, let's summarize what we have learnt in this episode so far. A set is defined to be a well-defined collection of objects. There are two ways of representing a set. There's the roster form and the set builder form. The roster form lists out all the elements of a set. The set builder form, on the other hand, gives the general characterization of the elements of the set by specifying a property. Sets with finite elements are finite sets. The rest of them, they are infinite. A null set is a set which contains no elements. Equal sets have identical elements in them. It's time for me to test your understanding of today's topic. Let me throw a couple of quick questions and see how well you fare. Remember guys, every correct answer gets you 1 mark. Are you ready? Here we go. Is 2, 4 an element of the set A is equal to 1, 2, 3 and 2, 4? True or false? The answer is true. Here's question number 2. 1 belongs to the set of prime numbers, true or false? Watch out, this one is false. Question number 3. 2 infinite sets are equal, true or false? Correct, it's false. Question number 4. What is the cardinality of the set open curly brace, close curly brace? Your options are A, 0, B, 1, C, infinity, D, not defined. The correct answer is A, 0. Question number 5. The element of the set X such that X is an integer minus half less than X less than 5 halves are, your options are A, minus 1, 0, 1, 2, B, 0, 1, 2, C, 1, and D, 0, 1, 2, 2, 4. The correct answer is B. So let's look at your scorecards. You are a topper high flyer if you have scored 5 marks. If you scored 3 or 4, then you're still an achiever. And if 0, 1 or 2 is reflecting on your scorecard, then you're a learner. Don't lose heart, there's plenty of reference material on www.topperlearning.com. And all of you, I suggest you should take the online test to keep a tab on your performance. You're not done yet. Pay attention because I've got an ideal answer for you to look at now. But before that, you must understand that mostly 1-mark questions can be expected from this topic. You may even get a 4-mark question. 6-mark questions are least expected from this topic. Sets help you in understanding statistics and probability. Mathematics is written in the language of sets, so it's important to understand the notation of set theory. This topic is a part of the unit Sets and Functions, which carry 29 marks in your final exams. You will be tested on knowledge and conceptual ability. You can expect questions on identifying a given collection as a set or not, converting one form of a set to another, finding out whether 2 sets are equal. And right now, let's move to the ideal answer. This one is based on conceptual ability and it's worth 1 mark. Here's the question. In a circle of radius 1 unit, consider the set of chords of length 3 units. Prove that this set is a null set. We have a circle of unit radius, so its longest chord is the diameter with length 2 units. Hence, no chord of length 3 units is possible. Therefore, the set is a null set. Simple enough, wouldn't you say? However, there's something more that I'd like to discuss with you. Actually, it's not me, but our guest who has some really good advice that will keep you on the path of maximum marks. Let's check it out.
Hi, I'm Taruni. With regards to this chapter, there are a few pointers. The definition of null set must be understood very carefully. The concept of the equality of sets must be practiced very thoroughly. One must not get confused in the forms of writing of a set. One of the forms is the roster form and the other is the set builder form. In the roster form, we generally do not repeat an element. However, if it is repeated, it does not change the set. But the order of the elements of the set is immaterial. It's not always possible to write an infinite set in the roster form. That's all from my side today. All the best. Study hard.
Well guys, that's all I have for you today. All I can say is, keep watching and you'll gain an edge over any question that may come up. You see, Ernst Mach once said, the mathematician who pursues his studies without clear views of his matter must often have the uncomfortable feeling that his papers and pencil surpass him in intelligence. Hey, but if you stick with me on Math 11, I can assure you that you will have a good time exploring the world of mathematics and excelling in your exams. Goodbye and take care.